class. Today we'll be discussing the concept of circle and circle. Now, circle, from what we know, just the plain circle, don't think too far. It's just a plane shape. One of the plane shapes that we know with 2 dimensions. Plane shapes are actually shapes bounded basically in 2 dimensions. So the same way you can say circle. But by definition, a circle can be defined as a regular shape that is equidistant from the what? From the center. Basically, a locus of point equidistant from the center. We can actually see circle in that simple definition. And just like any other shape, it has its own perimeter and it has its own area. That means there's formula for the area of a circle and the formula for the perimeter of a circle. And circle as well is one of the it's one of the conic sections, because conic sections includes the circle, the parabola, the hyperbola, and the ellipse. But this day I'm going to be looking at circle, basically the equation of a circle, and we try to go extend it a bit, because the equation of a circle is given as r squared equals to x squared plus y squared. But how did we come about this? And that is what we're going to be exploring in this class. Let's see, for instance, you are given a Cartesian plane of this for x and y axis, and you perhaps, let's draw it in this manner, and you draw a circle around this center in this manner. Then this part is basically called your origin and is referred to as your 0, 0 origin. And for instance, you took any point, your circle is actually centered at this origin, 0, 0. Then you drew a line, which is actually a radius, to any point on the circumference, any point. But I just choose to draw it, I could have chosen to draw it anywhere as well, such that this part of this coordinate is a comma b by assumption. It could be any, it could be pf. So they are just dummy variables, dummy. And I am expected to find the equation of this circle. Then I know from our line geometry, you should remember that the distance between 2 points is given as what? Is given as your r equals to the square root of what? Of x minus x1 squared. Like they do write it, or perhaps you could say x2 minus x1 plus y2 minus y1, all in brackets squared. Excuse me. Then you have this. Then you know that your coordinate is given as 0, 0, and the next coordinate is given as a, what, b, so that here is your x1, here is your y1, here is your x2, and here is your y2. You can easily do your simple computation by importing these entities into this place. Then what will I be having? I'll be having something from, say, r equals to the square root of your x1, or your x2 is a, minus 0 squared plus b minus 0 squared, such that we're having the square root of what? Of a squared plus b squared. And some can have it as x, like I said, this actually arbitrary number. I can have it as x1 to my y1 is nothing. It has nothing to do with to affect the answer. So in other words, this will be my equation of the what? Of a circle at the origin, say 0, 0. That is the equation of a circle at the what? At the origin, say 0, 0. But what if my circle is not situated, the center of my circle is not situated at the origin? What exactly happens to the equation? We have this. Our circle has shifted away to having its origin from 0, 0 to the point of having its origin to be a, b. And the radius is actually, the radius from the center, a, b, towards to x, y. And don't forget, it's actually a shape having a radius to be regular. Now, the same thing, I need to know the distance between this point, and I need to employ the concept of line geometry and the distance between 2 points. I need to recall that my r equals to, like I recalled the other time, my x2 minus x1 squared plus my y2 minus y1 squared as well. So with that, I have my coordinates to be a comma b and x comma what comma y. Here is my x1, here is my y1, here is my x2, and here is my y2. Then with that, I can easily compute for this, having here to be my r squared equals to, open bracket, x minus a squared plus what? Y minus what? Minus b squared as well. Then I do my simple expansion using my quadratic equation, and then my expansion, my expansion, I'm going to be what? X squared minus 2ax plus x squared plus my y squared minus 2by plus b squared. Then I have this. Then I can easily move my r squared to the other side such that I have it to be x squared plus bringing my y squared by arranging it minus 2ax minus 2by plus a squared plus b squared minus r squared equals to 0. So I'll be having something of this nature here. Then what next do I need is that I can say that I will say that, okay, let my g be minus a, that means whatever I say minus a, I should fix g, and let f be equals to minus b as well, and let my let c be equals to a squared plus b squared minus r squared. So all I need to do is just to do my simple computation, and I will be fine. So I have it to be x squared plus y squared plus 2x minus a plus 2y minus b plus a squared plus b squared minus r squared equals to 0. So what I just did there is my simple manipulation so that I can easily fit in these parameters upstairs. So at the end, I'll be having x squared plus y squared plus 2gx, since my minus a is g, plus 2fy, since my minus b is f, then plus c, since all of these stands for my c, equals to 0. Then I've simply landed at what? At the equation of the circle at the point A, comma B. That is the equation of the circle at the point A, comma B. Now let's quickly fix an example. Now, for example, if we were asked to solve for the what? Solve for the equation of a circle at the point 2, comma 3 with the radius, let us say radius 1, then what am I going to do? What am I going to do? Now, all I need to do is that I just need to follow this process, like I followed it, and I will arrive at my answer. So what do I need to do is that, okay, I come back to my question, I just come back to this place, and I recall that r squared is just x minus a squared plus y minus b on the bracket squared. My r is 1, so I have 1 squared, x minus this my x, my x and my y, and that is my a, I mean to say, this is my a comma b, I mean to say, a comma b, close bracket squared, plus my what? My y comma 3 on the bracket squared as well. So when I expand it, I have 1 equals to what? X squared by expansion, 2, that is, I mean to say 4x plus 4 plus y squared minus 6y plus 9. That is by expansion. I've just simply expanded it. So I do my simple collation so that I have it to be x squared plus y squared minus 4x minus 6y plus 4 plus 9 minus 1 equals to 0. So with this, I'll be having x squared plus y squared minus 4x minus 6y, okay, 13 and a half plus 12 equals to 0. And this is the equation of my circle at the point 2,3 with a radius of 1. Now, what if this was actually my question and I was expected to find the radius and to find the center point, the center coordinate? What am I to do? Okay, assuming this was my question and the question was coined out to be solved for the radius of this equation of the circle, hence determine the coordinate that centralize the circle. So what I need to do is that I just need to do my simple, I'm doing a reverse aspect. I just need to write this in this manner: x squared minus 4x, I bring it together, plus y squared minus 6y together. Then I could just easily take my minus 12 to that side, and also to this form. Then I will do my simple complete the square method that you know. That means I'm going to be adding half of this equation, half of it. I'm going to be adding it to both sides, because the law of equation says that whatever you do to the right hand side of an equation should as well be done to the left hand side. Otherwise, the equality sign will be thwarted. That means if I had to the right hand side and I do not do that to the left hand side, then there will be a thwarting in my equality symbol. For instance, so that I'll be sure I'm clear. For instance, I have x to be equals to y. Now, the moment I add 2 to this place and I do not add to this place, then something happens. Then this will become greater than y. Then if I had added to this guy, I did not add to this guy, this will become less than this. So, but if I added the 2 I added here to this side, then this actually becomes equal to. Do you understand? So that is how it is. So that note, I'm going to half of this guy, square it, and I will do that to the both sides as well. So I have x squared, because this is an equation, this is the right hand side of an equation, and this is the left hand side, minus 4x, so plus minus 4 all over 2 squared. Same thing with this guy, y squared minus 6y plus minus 6 all over 2 all over x squared. So I added this to this equation, and added this as well. They were not there initially. So I'm going to be saying minus 12 as well, plus minus 4 all over 2 squared, plus minus 6 all over 2 squared. So that note, I'll be having x squared minus what? Minus 4x plus minus 2 squared is just what? Is 4, plus y squared 6y plus minus 3 squared is also 9, equals to minus 12 plus 4 plus 9. On that note, I'm going to be doing what here? I'm going to be factorizing this so that it becomes, by factorization, it becomes x minus 2 squared plus y minus 3 what squared, and that becomes minus 12 plus 4 is 8, is minus 8 plus 9 is 1. So what do I have? I can write this as what? 1 squared, because 1 is 1 squared as well. So let's go that what? My a is just 2, my b is 3, and my radius is what? Is 1. And that is that for that. That's how simple it can be. Now you can give a chart to this, giving what? You can just solve for the equation of a circle, giving the point 3, comma minus 1, and a radius of what? A radius of, let's say, 5. So what will your answer look like? And try to do that as well. And you can drop your answer on the comment box for scrutiny. So thank you for being a part of the video. Please do ensure to subscribe, and so that you can be updated when we upload a new video. Thank you.